Honors Algebra 2, Chapter 4, Factoring Trinomials. We're going to factor today with this value here, a, the leading coefficient not being 1. And it makes it more confusing. So when you look at this problem right here, we're going to factor it. In the previous lessons, we were looking at how we'd break it up. Where does the 3x squared come from? Well, it comes from these two terms being multiplied. In the past, we just had x times x to give us x squared, but now we have that 3 in front. So the only way to get that 3 is a 3 times a 1. It's the only way we can get 3 through multiplication of two things, so or multiplication of integers in it. When that value becomes composite, which means non-prime, so you have more factors, it becomes even more confusing. These last two values come from the 7. The 7, only way to get 7 through multiplication is 7 times 1. And so they both have to be positive here because our signs are both positive. So this one's not too bad because our A value is prime and our C value is prime. But what I want you to see here is our B value here is 22. In the past, we've said the two numbers that add or multiply to be 7 but add to be 22. And that's not the case here because that 22x comes from OI, the outside inside. And when I look at this, how I have it written here, 3x times 1 is 3x, 7 times 1 is 7x, if I add those, I get 10x. So there's an error in here. So OI is very crucial for you to go back and look at. So what we need to do here is actually rotate or flip where we have the 7 and the 1. So we would actually put the 7. So we would actually put the 7 here and the 1 here. Now if I look at OI, 3x times 7 is 21x, and 1 times x is 1x, which gives us that 22x. So OI, that middle term OI, is affected by that A value. That 3 is going to multiply to that 7. So that A value affects our OI. So this becomes more complicated now when we need to logically factor this. So for this one, we look at this, our A value is an 8 to 10. These have multiple factors. So we're going to try breaking this up. How do you even start? Because we know it has to have an x and an x, but this could be 8 and 1. It could be 2 and 4. It could be 4 and 2. So we have options there. Let's start by looking at our signs. Because we have a positive C value, we have to be the same, either negative or positive. Middle number is negative, so these both have to be negative, negative. So I try to find things I know that has to be the case or has to be true for the situation. Now, when I look at the problem, I know it has to be like a 2 and 4, or I could read the problem again, and it could be 8 and 1. And so these are two setups. Now I can rearrange the 1 and 8, but right now it doesn't make a difference because our signs are the same. If our signs are opposites, if I rearrange the 1 and 8, it would be a different setup. So now when you look at the last problem, the last part here, C. The C value, the 10, comes from two numbers multiplied together. So it could be like 2 and 5. It could be 1 and 10. And I could rearrange these. I could put the 5 here and the 2 here, which is different. And I could put the 10 here and the 1 here. The reason why those are different is because this 2 is going to get multiplied to that number. So if I change that value, it's going to change the OI value. And so we can look at these and figure out 2 times what number here, and then 4 times what number here could give us a negative 21. So 2 times 10 is 20, 4 times 1 would be 24. And so we kind of have to go through trial and error here. 2 and the negative 5 would be negative 10, 4 and 2 would be 8, so negative 18. We can get a negative 22. We did the 4 and the 5, and then the 2 and the 2. Or we can get 41. So none of these work. So now we need to go to the 8x and 1x. Again, we could have the 1 and a 10, the 2 and a 5, 5 and a 2, or the 10 and the 1. So this 8 is going to multiply to one of these. So I think a lot of times I think about what number can I multiply that's close to that 21. So maybe the 2 would be 16. And then if I add the 5 times the 1, 5, I get 21. So there is the answer. So the answer here, if I factor it, 8x minus 5 times x minus 2. So that's a lot of trial and error to get through to find the answer to that. So same thing here, but the first thing we always look for, and I haven't really stressed this, but we need to start stressing it. The first thing we should always look for is that GCF. So we should begin by factoring out a common factor. All of these terms I can divide by 3. So divide everything by 3, pull out that 3, and you're left with this polynomial. The reason why it's nice is now our a value is smaller. So when we want to factor that, it's a little easier. Leave the 3 out in front. So now when I factor this, the only way to get the 3x squared is 3x and x. That prime a value is so much easier to deal with than the 9, the composite. We have a negative 5, so it's going to be opposites. I'm going to put the positive 5 here and the negative 1 here. The reason why I know that's going to be is because if 3 is going to multiply to 5, you get the 15, a positive 15. And then the negative 1 times the 4 is a negative 1. That's going to give me the positive 14 here. I want a positive 14, so I want the bigger values to be positive. So here is the factored form. So a couple more here for me to try or to give you examples of. For this one, we can have the 3x x. This has got to be 1 and 7 to multiply to be negative 7, but where does the 7 go and where does the 1 go? They're going to be opposite here because 3 times 1, 7 times x, I want them opposite because these are opposite signs. I want the bigger one negative, the smaller one positive, so give me negative 1's left over. For this one, I almost have a GCF, but 19, I can't divide by 3 or 2, so I just try factoring it. Now this one is a little more difficult. I have a 6, so I can do 2 and 3 or 6 and 1. I do know that both sides are negative, so that's how I'd start. So try thinking a little bit logically, like how to break it up when these are going to multiply here, these are going to multiply here, to try to have some kind of forethought with the problem. I would try 3 and 2, and I'm kind of guessing there. But then I'm trying to figure out 3 times what and 2 times what to give me negative 19. And I can kind of see it already because I know that if I do 2 times 5 here will give me negative 10. And this 5 is going to multiply by a negative 3 to give me positive 15. And 3 times negative 3 is negative 9. So now I have negative 9x, negative 10x, so that's negative 19x. So I kind of saw that, but I guess I'm 3 and 2, but then I kind of had some thought process in my head to get the 5 and negative 3. If you don't get that right away, trial and error. You just keep trying numbers to see which ones work, but you need to check the OI. The OI lets you know that negative 19 lets you know if you've unlocked that little puzzle. So one more here. Let's have you try this one. Here's your problem to turn in beginning of the hour. So good luck. See you tomorrow.